Linear changes of scale and origin, and you're going to find that this is very much the same as when we did this for discrete random variables. So the situation is the same as it was for discrete random variables, in that changes of origin, adding a fixed number to the domain, affects only the expected value, but changes of scale, that's multiplying the domain by a fixed number, affects both expected value and variance. This is illustrated in the diagrams below using a uniform continuous This is illustrated in the diagrams below using a uniform continuous distribution. This is this type of rectangular distribution that we have here. But the principle is the same for any type of distribution. So I've set up this rectangular distribution where the PDF is just this line here, which goes between 2 and 8. And because it's symmetrical, that means that the expectation or the mean here is at 5. The variance has been set up to be 3. If we just add something, so we can see here that with these values down here being 5, 8, and 11, we've just added 3 to each of the numbers here. And so the mean here was 5, the expectation. Here it's 8. So we've just added 3. But it hasn't changed the spread, so the variance is still 3. Moving the distribution 3 units to the right has increased the mean by 3, but has not changed the variance, which is a measure of dispersion. If we look at this one here, we've got 4, 10, and 16. So how have we produced that from the original? It looks like we've doubled it. We've multiplied everything by 2. It should be clear here that the values are doubled. 4 is 2 times 2, 10 is 2 times 5, 16 is 2 times 8. The mean has doubled, so it's now 10. And the variance has increased by a factor of 4, as variance is a squared quantity. We'll talk about that again in a moment. The point is that just moving the distribution left or right affects where the center is, but not how spread out it is. Dilating the distribution, that's by multiplying, affects both, unless the center was at the origin. If the center was 0, then anything times 0 is still 0. Suppose we have a continuous random variable x and a continuous random variable y defined as y is equal to ax plus b. So we can see we've multiplied the x by a and added b. Then, just as we had with the discrete random variables, the expectation of y is a times the expectation of x plus b. So the expectation or mean affected both by the multiplication and the addition. The variance of y is a squared times the variance of x. So it's only affected by the multiplication, and this is squared because variance is a squared quantity. The standard deviation of y is just a times the standard deviation of x.